Good morning, good afternoon, good evening from wherever you are watching this video from. Welcome to my lab life, and today I want to discuss an immunological technique that we call ELISPOT. And if you're new here, my name is Lucy and I'm so glad that you could join me. Kindly hit that subscribe button. This is a scientific channel where we talk about academics, we talk about laboratory sciences, we talk about life and work balance, and so much more. So feel in the right place and kindly like, share, and subscribe. So today we talk about ELISPOT, and this technique represents one of the most sensitive technologies for the detection of immune cells that secrete signature proteins, for example, those that secrete cytokines, and it therefore represents the state of the art for the detection, measurement, and functional analysis of immune cells that you can, use when we are diagnosing disease. So ELISPOT assays, we will usually measure the secretory activity of individual cells, and we normally will present the results in terms of dots that now we can then measure using a machine. So the unique sensitivity of ELISPOT assays compared to other assays that we call supernatant-based measurements, that is, for example, ELISA, protein cytokine arrays, or cytokine bead arrays. So the unique sensitivity compared to this usually will result from the fact that the analyte that is in this particular assay is captured directly around the secreting cell as it is being released. And this happens before it can therefore then be diluted into the supernatant, or even absorbed by receptors of adjacent cells, or even degraded by proteases. And that means it gives us an accurate measurement of the secretory activity of those particular cells that you're analyzing. ELISPOT assays are more sensitive for detecting rare cells than, for example, the flow cytometry-based techniques. And these rare cells include the tetramers or the intracytoplasmic cytokine staining. Now, since the antigen-specific lymphocytes will frequently occur in cells we call PBMCs, in usually frequencies that are very low for detection by the other techniques that we have mentioned, this method of ELISPOT therefore has become the most sensitive and robust technique that can help us to directly monitor ex vivo, that is maybe like T cell and B cell immunity. Now, by measuring the frequencies of the antigen-specific cells and the types of molecules that these lymphocytes are secreting, the ELISPOT assay is not only being established in giving us the magnitude, or what we call the clonal size, but it is also helping us to understand quality. For example, the effector classes of these cells, let's say T helper 1, T helper 2, T helper 3, etc. And that helps us to understand the antigen-specific immunity. So this is how the assay looks like. So usually in your well you have the capture monoclonal antibody, and then we normally will add our analyte. We have the detection monoclonal antibody that is bound to biotin, and then we normally have the streptavidin enzyme that now will help bind the biotin to streptavidin, and then there'll be the precipitating substrate. So in more details, this is your well, and you have coated with for example, the interferon gamma antibody overnight, and then you'll come and wash and also put serum for blocking. And then once you have washed, usually you'll wash 6 times with PBS buffer, you will then incubate the cytokine-secreting cells. So these are the secreting cells that will produce cytokine. So you also add the respective stimulus that will help the secreting cells to produce cytokines. So in this case, the cytokine that we are looking at is interferon gamma. So we first put the interferon gamma antibody. Now we are adding the cytokine secreting cells with stimuli such as peptide, PHA, SEB overnight at 37 degrees with 5% carbon dioxide. Then the next day we wash with the PBS again 6 times. So we are expecting that our secreting cells are going to produce now the interferon gamma because they already have the stimulus to help them do so. Then this day after you wash, you incubate the biointermediated detection interferon gamma antibody. So you still put an antibody, interferon gamma, but this time one that has been bound to biotin. And you incubate this for 1.5 hours at room temperature. Then you wash again 6 times with sterile phosphate buffer, saline buffer. And then you again incubate. Now this is an enzyme, alkaline phosphatase, linked to streptavidin. And of course the streptavidin is going to bind to the biotin on the antibody. And you do this for 1 hour in the dark because it's color sensitive. Wash again with PBS. And then now we add our color reagents for 10 to 20 minutes. And then we will usually decontaminate the plate by adding 0.05% of twin-20. Then we wash off the color reagents and we allow the plate to dry. And then now once the plate has dried, we are going to be left with the spots. So usually, for example, in this case, when you use alkaline phosphatase, you get a black colored precipitate, and it normally appears as spots at the site of cytokine localization, with each individual spot representing an individual analyte secreting cell. So whichever place there was a cytokine, then there'll be an individual spot. So the spots can then be counted with an automated ELISPOT reader or even manually using a stereo microscope. So this is how the plate looks like, and I think you can see the different spots. Some are very concentrated like these ones, others are lightly, and so on and so forth. I just want to differentiate these 3 terms: ELISPOT, Immunospot, and Biospot. So ELISPOT is that assay that we have just discussed, used to detect and quantify cells that secrete specific proteins like cytokines and immunoglobulins, and it is a modified form of ELISA. But now here, the cells are allowed to secrete the proteins onto the membrane, then they can be visualized by enzyme-linked antibodies. Now, it allows for single analysis and therefore very useful in immune responses at granular level. Immunospot, on the other hand, is the brand name of the company that makes ELISPOT analyzers, and so sometimes they can be used interchangeably, but ELISPOT is the technique while Immunospot is the brand of the ELISPOT analyzers. Biospot is also another brand name for a chlorine tablet disinfectant that is used for surface and equipment disinfection, and therefore not related to ELISPOT or Immunospot in this context of immunology. So next, I'm going to just take us through a demonstration that we had at Cambridge here in Kenya, where we were just being shown how to load a plate, how to visualize the ELISPOT plate and count, and so on and so forth. So stay tuned until the end, and thank you so much for watching until this point. And if you are new here, kindly do not forget to hit the subscribe button. And for us who are coming back again, thank you so much. Keep liking, keep sharing, and let's keep it at myLAB Life.
Today we will go through the basic workflow, which includes scan, count, quality control, and then the managed data. We start with scan. So once you hover your mouse and you click scan, it will initiate all the hardware that's in there. So it makes the stage, checks everything, make sure that we can communicate with all the hardware. Okay, and now you have the option to choose the full plate scan, partial plate scan, or strip scan. We always suggest use the full plate scan in case in the future if an auditor comes and he'll be curious what's on the other well, why these haven't been analyzed. So I would go with the full plate scan. All right. We saw that before. So this is the view that you're going to see when you are scanning the plate. Right now what we can see, we have the plate name, the type of naming, the user that's logged in right now, and the scan mode. Then we have the base scan control. This is the capture format. So that's what I mentioned when I said these are like templates. That means if you buy another plate, if you have another provider and you want to create a different template for your plate, for your assay, you can create one. And we're gonna do that in a second. Right now, we use the reference plate template, and I'll show you first how easy it is to scan the plate, even with a random template that has not been designed for this plate. You can already see that the red circle, which is the region of interest, is not aligned with the actual well. Normally that would be a problem, but we have a feature that's called auto pre-alignment. What it does, it automatically adjusts the position of the well, so you don't have to. It works well when there is a good differentiation between the well itself and the background. So right now you can see the border clearly, and there should not be a problem. Sometimes, let's say with clear plates, you don't have such a differentiation, so you might use fixed position, so you can have a look, you tell the software where is the well, and then it will not try to correct it automatically. It will just stay at the position that you told it to stay. Okay, so that's just the display of the template. If you would like to dive into more settings, you click the dashboard right here. Once you click, it will show you some more details. So again, we have the capture format. Now, if you click on it, it lets you choose from the preset templates that we have. You can create more. For now, we can use the reference plate. The next one is the path for the plate. So we strongly advise to use the D drive for saving the plates. The reason for that is it will be organized. If we come to do a backup during the maintenance and you save it on the desktop, it just creates a mess, and it will run out of space quickly. So remember to use the D drive. Plates is what we also advise to use. And now we have the centering mode. So that's what relates to the red circle, which we call ROI. We have a few options. So we have the fixed preset position. That means whatever you set up, the software will not try to correct. It won't try to adjust it. We have auto pre-alignment. That's where the software tries to find the position of the well. We have auto pre-alignment user verified. That means the software is correcting the position and then asks you if it's correct. You can change it later. Then all the other, this is auto-centering. What it means, it tries to correct every well on the plate. This is mainly used for strip plates, where you put the strips separately. The reason for that, this is a pre-made plate, so all the wells are in a certain position, they don't move. But with strip plates, the strips move. So then it will be slightly out of alignment. So I would use that only for strip plates. For now, let's go with auto pre-alignment. Exposure, we can use auto exposure for each well, preset value, and user defined. So we can put the exposure slightly higher. You asked about the navigation, if you have to do it for every well. What it's used for, if you set the exposure, you can check different wells to see, because if we okay, so let's say this well. The exposure looks good now, but we moved here, and you can already see that it's slightly brighter. So when you set up the exposure, you can put the value and then just check a few different wells. Make sure there is no underexposure, there is no overexposure, that it's just right. That's a perfect timer. Another one. It looks good. So now we can proceed with the scan. We go with start. It asks for the name. So let's just...
Oh, the alignment didn't still go.
Yes, that's literally the next step.
Okay.
Okay, and now you'll see how the software corrects the position.
So it's randomly picking wells.
It's not random. It picks the three corners, and if it needs more, it just picks another wells to align it. Whenever it's ready, and it calculated all the positions, it goes to A1, and now you can see.
Yeah.
Yes. It is fast. Yes. So, for customers that analyze like hundreds of plates every day, we have another solution. This analyzer is not capable with the stacker. It's not like suitable for the stacker, but you have the analyzer, and right next to it you have a plate loader where you put. Yep, and then what you can do. You can put like 50 plates, you can go grab a coffee, and the software will scan and count for you. So you come back, and basically we have 50 plates that are ready for QC. We have a lot of fibers, so
Yeah.
So the spots are usually made or captured at the bottom, not at the sides.
yeah, no.
At the bottom
So only the bottom of the well. That's what you're interested in. We're never interested in what's outside the well. It's just reflection. So now you get the overview of the plate, and that's what you could see with your bare eye. And now it has been captured within a minute. So when you open the File Explorer, as we see, so we have the D drive plates, and this is the plate that we just scanned. So you open the folder, and then you have a bunch of files. These, of course, as you can see them, these are single images for each well, and it goes to the we can maybe sort it by the type of the file. Okay. Then we have the overview of the plate in a single image. And then we have a text document, which is a scan log, and it shows you pretty much all the data. So we have the name of the plate, capture format that was used. We have the position of the stage, so we can verify the exact position of the well. Date, time, user, which scanned the plate. We have the resolution and the RGB values. So in case you need to track down or we have some regulated customers that need to comply with certain rules, you can go back and you have a full detail of what was done on that day during the scan. Right, and that's it for the scan plate. When we go to count and QC, you'll have another folders within the folder that will show you more details like the counting parameters, and then the QC will show you the differences, the changes that you made during the quality control. It will list everything. So again, if you need to check after a few years what has been done on the plate, it's in there. All right, we can so now we had a template that worked with the plate, but now I will show you what to do if you brought a new plate with your assay and nothing really works. So the first step is to go through the existing templates and find one that's close enough. So that gives you a good starting point, right? Because if you, let's say, which one was that? I think this one. If you have this one, of course you can adjust it, but you'll have to do a lot of changes to get to the point. And if we select, let's say, this one, it looks much better, so we can start with this. Okay. You already know that we're in the scan module, so now we go to advanced settings right here. And this is where it gives you some more features. For example, you can change the naming mode. You also have a barcode reader. That's useful when you have the stacker, because you can put the barcodes on each plate and the software will scan automatically and name the plates accordingly. For this type of like one-time scans, I would suggest to prompt for the plate name. So you type whatever you scan and you type it manually. Now the most important part in the advanced settings is the capture format selection. So if you click here, you already know the list. This is the list of the templates here, but it looks more advanced. So now if you hit edit, you'll see that now we have all the possibilities to change the settings for this template. Another very important note is if you want to change something, if you want to create your own template, you don't want to change any of the existing templates, because then someone used this template 10 times already, and you come here and you change the parameters. So before you start tweaking any of the settings, click the duplicate button here. And what it does, it takes this exact template and creates a copy. Then if you have a copy, you can change the name and change the settings, and this way you don't interfere with others' work. So that's what we're gonna do right now. We have a template that kind of works with the plate that's in there. We duplicate the plate, and now you got a notification that the new user plate profile copy of the one that we selected has been added to the list. Now we hit OK, and now we are working on a copy of the template, not the actual original template. But of course you want to change the name, right? So we can name it CTL training. Whoops. Okay, and now let's see what options we have in this. So first of all, we can change the light. Turn it off, it's dark. We use the bottom light. This is what you get with the bottom light. Of course, it does not work with this plate, so we stay with the top light. Another very important setting is the exposure. So you want to avoid overexposure. Let's go for something less crazy. Oops. Okay, so now this is clearly overexposed, right? You get a white spot. You cannot see the background. You will not get a good result if the plate is overexposed. This is still slightly overexposed. We're not getting much detail here. Just to make sure we can lower it even more. Okay, that's okay, but remember when you change, you have to check other wells. This looks slightly overexposed, so we can drop it to like 100. We check other wells. Looks good. I wouldn't suggest to play with the RGB values because then it's like very difficult to get back to the actual good result. What's useful here, sometimes if you insert the plate and it's too yellowish or too blue, you can click on the white balance and it will adjust for the actual color of the plate. If it's not accurate, you can check and go with other wells and find the actual white balance that works for you. Okay. And another useful feature is the alignment. So in this case, the alignment settings that we have here in the advanced menu, you would use if the software cannot align automatically. So you have a problematic plate that's very similar, has a very similar background to the edge of the well, and the software cannot correct it. So what you do it manually. And to do that, we have the three corners, remember, that I mentioned about. So we have the A1, A12, A1. And now what we're gonna do, you click on A1, and now you manually adjust the position of the well. Once we have the good position, you click on the A1 again, and now you can see a check mark. That means the position has been adjusted. Now A12 is highlighted, so you click on A12, the analyzer moves the plate to A12, and now you can again use the navigation buttons to align the plate. Whenever you find good position, again you click on A12, we got the check mark, H1 is highlighted, we click on H1, and again we adjust the position. Whenever we're done, we put the check mark and see here, stage alignment correction. This means the stage position has been corrected. And now we have a template that's ready. So this is the workflow that you'll do before, when you have a new plate, you set up the template, and next time you don't have to do any of that because it's saved. So we apply the changes, we save the plate, save and exit. To change the name here, you'll need to restart the software. Right now it's a copy off, so we do that. We go back to switchboard, we close. And now when we start the scan, it will appear under the new name, and you don't have to change anything.